Right. Thank you, Philip, for having me. And I'll go through my attempt at a provocation of framing architectural robotics as something that's, I think, sort of wavering through many of the presentations, introduce some more terms maybe, but ultimately trying to talk about sort of the body of architecture as a robot as opposed to fabricating with them or basically creating interactive constructs. So I think anthropomorphism is one word that hasn't really appeared yet. I think it's really crucial, which is basically the association with living and non-living things by projecting basic human traits of behavior into them or trying to discover them or basically project them into it. So I think architecture has had its fair share of that as well. I love this Bernini sketch of trying to either pitch how great the idea is of like a church that basically is about to strangle you, or basically attributing larger powers, let's say, to an imminent kind of human form at the scale of a all-powerful church. So is this basically the first basically architectural robot, you could ask? But I think there's also profound changes that go through how we design and how we implement. And I think one of my favorite examples here, which I'm continuously expanding a bit, is this transition, let's say, from one of the more complicated everyday life-death kind of mechanical complex things, if it's just the rotor control head of helicopters, mainstay of, like, let's say, 20th century kind of invention, and how it basically evaporated with basically feedback and control. So you look at the drone, which is the most sophisticated kind of flying object, which is basically just 4 fixed rotors, no more mechanism. It's all in the algorithm. It's strange, right? Like, so something seems to be happening with all the achievements of hundreds of years of mechanical engineering through analog computation, which is basically physical, embodied kind of decisions turned into objects which are assembled to bring this forward, and it's gone into algorithms. But of course, that hasn't stopped that, and it hasn't even yet arrived in mainstream construction or objects at that step. But the next step is that you take any arbitrary object, in this case robotic arms, and actually let them learn and figure out by interacting with the physical world, in this case the famous Google grasping collective learning. So that's a crucial next extension of that, right? Because it's not a purpose-built machine now, but it's like by discovery. It's not simulation, but by discovery in the physical world, figure something out that it didn't know it could do, right? And then collectively sharing that, right? So I'm curious about these trends and these developments, which are often not pitched that way, but they're more like observations in retrospect. So in my own work, my individual work of exploring this robotic fascination, I've always tried to construct basically domain-specific robotic interpretation. So when I was doing concept cars, Mitch was mentioning that in the Smart Cities group, I tried to do an athletic car, which is actually articulate and actuated. So if you look at the physical prototype, so it's quite interesting how this is like a 15-minute sketch, right? Literally throwing together foam core and strapping servos on it, suddenly changes from basically the formal to the behavioral. At the most subtle level, it's just an animation, but in its extension, it becomes expressive in its behavior. And it went on with the Who, What, When, Air tower project at MIT, together with Phil Block and John Snavely and Peter Schmidt, when we basically explored the extension from the mechanical, which is basically statics and architecture and engineering, towards algorithmic control. In this case, humans are still remote controlling the tower, but basically giving up the fixity through material organization with, again, basic feedback and control systems. And then going further, in the past years, of really making a smaller version of this to enable programming of these things in a desktop version, of like a much more loose tower, which is actually now an active bending actuated tower, which has very difficult kind of to simulate properties because it's bendy and floppy and so on, and just using feedback sensors to figure out when it's standing straight. So it doesn't even know about its body, right? It has no model, no knowledge whatsoever. It only has 6 degrees of freedom, and it actually searches through possible positions using the physical world and its body in the world as the function. So it's a bit, and then ultimately the last project, which is the main focus here, which is the flexing room, which takes that feedback now to a super simplistic but a social domain. Right? So as in how many people are in this enclosure at any one time as the feedback rather than performative measures. So there's a crucial, I think, also bias in our interaction with robotics, which is, I think, explained by our own brain. Like the majority, almost like 90% of this now outdated but still helpful understanding of the somatosensory map by Penfield is dominated by outward perceptory attributes like the skin, the eyes, touch, etc. And actually tiny, tiny amounts is actually internal, like to our own body, which was the question I was asking yesterday. I think we have done the same basically to our robotics, which tend to be objects mobile in the world, outward looking, sensing to the world, like autonomous cars, the sensor array, right? It's all about the outside, right? Tesla has a steering wheel touch sensor, that's about all, right, to the inside, right? Maybe airbag sensors, etc. Right? But ultimately, how big can robots be, right? So if you look at nature, there's a certain limit size, it seems, like which is the blue whale, biggest living being, right? Is that sort of the extent? But our buildings are vastly bigger than that, right? So what else is there in terms of the constraints? If you look at whales, one of the, I guess, famous examples of experiencing basically intelligence from the inside is Jonah and the whale. Right? So we don't have much evolutionary kind of trajectories of actually experiencing intelligent rooms from the inside, because that usually means we're being eaten. Hence, you're removed from the gene pool. Right? So we just don't have the capacities of actually, it doesn't matter if we feel what we ate, right? Because it's no longer place into that experience. So I think it's really, we're blind in understanding how robotic objects can look to the inside and actually interact and sense that, right? We're really doing that from scratch. The only other sort of precedence really is, let's say, in collective intelligence, like forests or ecosystems that are much larger, right? But I think architectural robots are this interesting intermediate scale, right? Which is much bigger than any living intelligence that we know as objects. And also we inhabit them. We still have a traceable sort of scale perception of them as we go through them. But they're not ecosystems at the scale of like ecological sort of constructs. So I think it's an interesting transition, right, from basically strapping ourselves in dumb machines like cars, where we have to be like secured, to maybe wearables, where we become basically exoskeleton kind of robots, extensions of humans. Or what I hope to try to frame with these projects is to push ourselves to inhabit robotic constructs rather than being just in interactive or automated sort of environments. It also has to do with, I think, muscle memory and, as I said, learning, letting the structures and the designs actually figure out what they can do in the world and using feedback of human responses as the guidance rather than animating them. And learning how the human always plays a crucial role in these things, right? Both as maybe constructor, inventor, but also inhabitor. And basically, as I said before, being enclosed in it, and looking at these structures. And then one main important critique I want to make here also, with all the amazing work that we've already seen, I'm very wary of the model sort of dominance, right? We've seen amazing projects by Andreas today and yesterday also of making these life-linked abstractions and control abstractions, but I kind of seeing, let's say, the movie Gravity, which I love for its simulation, right? But it's so ultimately perversity of actually having a previous simulation of a movie play out at real time, strap the actors on robotic arms to insert them in that pre-visualized world, right? To basically have them one-to-one linked and just fill in the last human bits, right? And they struggled immensely with that, with timing, right? How human expression could be fitted into the predetermined timing and visualized part. Fascinating, but I think we have to be careful to not fall in the same trap, right, with robotics and these kind of complex environments where we have like a separate world which is simulated, which is basically running live, and the physical world drags behind it. But instead, we should actually, like in the robotic arm world, or in what I'm trying to frame with the project, be very, very open-ended in terms of what we sense and really rely on the sensing, the mapping of how we perceive the world as the crucial model in the physical world being the actual simulation, so to say, rather than the other way around. Right? So in the flexing room, in the remaining minutes, that was very simplistic, just a Kinetic sensor that counted how many people were in which pose. The structure cycled through 20 initially random poses and basically learned which ones are attractive to people and which ones are not. And this is super simplistic for my lack of ability to quickly implement that in a few days. And it's a pneumatically actuated structure with 24 actuators in this case that are basically striking these poses and basically trying to trigger in a response in the humans that inhabit it, and then basically also have a sort of surround acoustic signature due to the badly sort of buffered sensory pressure sensors in the actuators. It's all done with these flexing actuated bows. It's a bow and arrow kind of principle. So each one is pre-tensioned. That's why they can stand on the actuator air muscles, and then basically suggest different poses. So it's not interactive. It doesn't respond to the person. It's simply tracking of whether the person stays or leaves over time. And just a last glance at the sort of process. So I built these structures on my own in my office, like doing all the actuators, everything, like in several months of sort of monastery kind of enclosure, because I believe that a lot of these details are really crucial to understand and get the sensibility about the minute decision making in this sort of formation of the physical. And then also constructing them gives you sort of a perception and feel for this robotic entity that is in development. And in closing, I think the living architecture for me, and these are really, really tall like orders, and I don't believe anybody should agree or even be able to achieve that, but I think we need really to look beyond material programming, which is basically fabrication, what we're currently doing to embed behavior and other things, into creating vehicles which are about lifelong learning. Right? So I think design really has to start with the construction of the architectural robot, I call it, or any sort of built form, so it can actually evolve and see what its impact on the world is over its lifetime, right? As opposed to see them as endpoints, right? Close and fix basically the building at the point of delivery, backed up by all the simulations we've done beforehand, right? And be completely blind to what happens afterwards. Right? Then I think leverage the unique quality of this architectural scale, right, to define multitudes of social sort of scales within it, and within its large extent, which goes way beyond the interaction paradigm of screen sort of and close human sort of interactions. And ultimately, I think it's time to really address architectural robots, and you can call it anything you want, architecture also without the robotic if that quirks you, but to build in responsibility and agendas to these constructs to actually be caretakers of the values they were basically sent into the world out into, because I don't trust humans with their short-term kind of perspectives on enforcing these. So it's really crucial, I think, to develop them as intelligent shapers of society and think about how we can basically achieve that. So thank you very much.
I think we have time for one question.
Great work, Axel. A quick one. What's your perception of the utility of framing the entire building as an agent, as opposed to framing the building as an ecosystem of agents?
Yeah, that's what I was trying to frame in the beginning, right? The difference between ecosystem, let's say, which is a collective sense of loosely associated and surviving, let's say, individuals, towards what I perceive at this unique scale of architecture, which I think we have to invent, in a sense, as a being, right? Because it doesn't have ecological precedents like that, right? And of course, every living being, we know that from biome, is also collections, right? But I think due to the sensory bias, we're not aware of that, right? So maybe directly, actively direct. We don't have conversations consciously with that, right? So I think it's important to develop a sensibility what that means, right? Like, and I try to make the simplest, maybe, let's say, in terms of energy, you could basically embed, like educate, let's say, or upbring the building to conserve energy, right? And that's its goal, but you don't tell it how, right? And over its lifetime, it will figure ways out, how to use its basic abilities, degrees of freedom, etc., to do that, right? And I think architecture is, in a way, very fascinating because it's such a loose set of degrees of freedom, and I call that, again, not to make it technical, but for lack of a better word, may have 1,000 doors, 1,000 windows, right, and lights everywhere. Nothing is really directly linked, like in a mechanical system, like a walking robot. Everything is deterministic in chains of easily, relatively simulatable, right? But to like simulate the wind draft that happens to form after a few minutes between the front door and like 3 doors down into a big structure, right? Is really, really difficult, right? And tends to be suppressed by mechanical determinism, right? Forced air systems, et cetera, right? So I believe there's a much deeper, richer depth in the actual physical world, using the world as the model, right? And using sensors and simulations just to do near future predictions and guiding of that, right? And I think we need to invert the whole model, basically. I think we're following the wrong paradigm in a sense by relying on our achievements of abstractions, right, and rest on those laurels. I think it's time to actually invert it. So, thanks.
Thank you.